Hi, and welcome to this short video talking about the identity problem in the multi-cloud scenario. When an organization moves to a multi-cloud environment, one of the first questions a developer will ask is, how do I access my S3 bucket in AWS from my GCP cluster? Or any other permutation thereof cloud service providers and resources. This is an unsurprising request. However, the solutions to these problems today are surprisingly inadequate, especially when security and compliance is considered. CISOs, or Chief Information Security Officers, and security engineers and operators need to ensure proper identity and access management across each component. In this video, we will elaborate more about why today's solutions fall short and propose a shift in the perspective of managing workload identity and access, moving from a platform view of identity to an organizational view of identity. After all, we have a central organizational view when we manage user identities. Why don't we do that for our workloads? So let's start off today with a very simple multi-cloud scenario. So over here you can see we have three different clouds, IBM Cloud in blue, Google Cloud in green, and AWS in yellow. And the idea today is we want to show how we can access resources from one cloud from workloads in another. So the idea today is we see that every different cloud provider has its own identity framework. They have their own trust authorities, they have their own identity providers which attest the infrastructure, and each of them have their own IAM component. So IBM Cloud, GCP, AWS each have their own IAM components. So being able to access resources within the cloud today is easy because it understands its own identity framework and access control. But the question today is, how do we want to do this across multiple clouds? So just to reiterate, today there are identity frameworks within each single cloud provider. However, the problem that we are addressing is, how do we do cross-cloud resource management and access control and management in a secure fashion? So we'll start off with, how do we do things today? So the most simple solution to this, which is also very insecure, is that of creating a long-lived credential from another identity provider from cloud, and then taking that credential and putting it so that it is accessible by another workload. For example, Kubernetes secret. So in this case, we'll go to GCP IAM, create a role, create a X509 certificate or GWT, and then we'll take it and then put it in Kubernetes secret, so that workload in our cloud such as IBM connects. So this obviously is insecure for multiple reasons. The first is that we are generating a long-lived credential, so there's very little auditability. It's difficult to calculate the blast radius on that. So in that sense, it is insecure. The other aspect of this which is insecure is that the process in which we are taking this credential and putting it onto making it accessible to another cloud is usually done by a human operator, or is done in a manner which is not auditable or not easy to keep track of. So the method to do this is insecure as well. So the other way that is another approach that people take is through some sort of federation. So the idea is we want to teach a cloud provider such as Google Cloud here how to recognize IBM identities. And so the idea is we will configure GCP IAM to recognize how to authenticate IBM identities and to use them. And this generally is more secure because there are no private keys that you have to pass around any sensitive credentials. So great. So we talked about the insecure solution, we talked about the more secure solution through some sort of federation between each cloud. However, let's talk a bit about why this second more secure approach also has several problems with it. So first of all, talking about federation between clouds, support for this varies between clouds. So for example, if I have an AWS workload that would like to access a Google Cloud resource, this generally today is easy. And Google Cloud has a beta feature which makes that simple. However, if you take the opposite approach, where we want a Google Cloud workload to access AWS IAM, this today is not easy to do, and it's actually very involved. It requires webhooks and operator installation within a Kubernetes or OpenShift cluster in order to do some exchange of tokens. So one is there isn't a symmetry in how this is easily done between clouds. The second point of this is that each identity provider, each cloud provider's identity has a different schema. There are different definitions of how security is managed, certain properties in which our workloads would have. And what this means is that there is an inconsistent schema across the different identities. And because there is an inconsistent schema between providers, what needs to be done when you're doing federation is that you require some level of custom mapping. There is an issue about maintaining the trust relationship between every cloud. For example, what does one field really mean in one cloud versus a field in a different cloud? And for example, one parameter may be EUDE in a cloud which is talking about data center, and another may be talking about a region or a language. And this brings us to the last point, which is what's happening with federation today is we have to do it between every single cloud. And because we need to do this pairwise configuration, it will become unmaintainable. So this is an illustration of the second method, right? When we are creating pairwise cloud configurations, what happens if you see just with 3 cloud providers, we need at least 6 different configurations. So what happens is that as we grow the number of providers or different services that we use for each provider, this number is going to increase and management is going to become difficult. So what our proposal is the idea of universal workload identity. So in general, and traditionally, organizations have been using a single cloud provider or have their own on-prem data centers, and the idea is that they have kind of one platform that they go to. But as we are moving towards a multi-cloud scenario, now the concepts of platform identity that were good enough to represent the entire organization, because all the workloads were in that single platform, is no longer good enough. So the idea that we are proposing is that we want to have universal workload identity. We want to define identity and workload identity as an organizational concept. And how we're going to do this is through a set of technologies. So the idea is we are leveraging Spiffy, Spire, and as well as a new project that we've created called Tonyak. And here what we want to do is we want to provide a zero trust workload identity framework with strong workload attestation with Spire and cloud provider plugins with each OpenShift or Kubernetes installation. So the idea here is we're going to provide a way in which we can define an organizational schema and want to install this component on every single cluster that we have. The schema will look consistent across the workloads over every cloud that they reside on. So what we want through this is we want to have a way to manage and audit all the workload identities, be able to have them be backed by strong attestation no matter which cloud they are on, and be able to have a consistent way to define policy across the various clouds. And because we have a single identity schema and a single identity authority, what happens now is that we can now configure each access control management system or resource management system in a consistent way. And there isn't a lot of complexities in needing to maintain the relationships between every single cloud. So the idea here we have is we are adding this additional layer below the container orchestration system that is using Spiffy, Spire, as well as Tonyak, which is a new project around managing the identities in Spiffy and Spire. And what this is doing is that we create this identity layer. We can see that this attests the different cloud providers, so we still maintain security through strong attestation of the platform. And what happens now is we have a consistent Spiffy ID, which represents the organizational ID, and a organizational trust authority. So all that needs to be done now is this organizational trust authority can be configured to each cloud provider, and this will allow you to be able to perform cross-cloud access and cross-cloud resource management in a way which is simple to do. So in conclusion, we've talked a little bit about the workload identity problem, we talked about the access problem across clouds, and we introduced the concept of universal or organizational identity. And what we hope is that we are able to build a framework in which we can bridge the system between the different cloud providers and different services, as well as the consumers of identity and access control management, such as Vault or IAMs of different clouds. So to find out more, we have a blog post written which will contain more details. The link is in the description, and we hope to see there being improvements in how we manage workload identities in our organizations.